So picking up where we left off, the object smdll.temperature, I'm going to set the temperature property of the DLL or the .NET library to the value that's in the current sample. That's so I'm pulling the current sample, current test number, and the temperature value. And we'll see this, and when we run through the automation, it'll make a little bit more sense because you haven't seen the analysis. But inside the analysis, there's only two fields. One is called temperature, which is a numeric field, and the other one is temperature label, which is a calculated field. But as we saw in the .NET DLL, the temperature label is defined once we pass in the temperature, or once we set the temperature value of the DLL. So once the temperature has been set in the property of the DLL, we know that its purpose was to calculate what the temperature label is. So the temperature label is already defined at this point. So all I need to do now is set the return value equal to the value of the temperature label property inside the DLL. So that's pretty much it. Then this value is going to return back up here. So since I set this value and we know that this was passed by reference, the return value variable was passed by reference, so any change I make inside this subroutine is going to be reflected in this value up here, or this variable up here. So all I do now is return the return value, and so now that should work. So go ahead and click Save and Close, and before you can use this calculation, you need to compile it. So go to Calculation, go to Test, and pick a test sample. In my case, I went ahead and set one, I already had one, and this was the name of the analysis, which we'll take a look at. So I had picked a sample for testing, and I'll go ahead and click Calculate, and you'll see it says just right. It's getting this value just right from the DLL. When I click Calculate, it called that VGO wrapper, which created an instance of this DLL, passed it the value of the temperature, and as you can see here, the value of the temperature must have been within, so the calculated value was just right. So here it is, just right. So the value of that sample analysis should have been, the result should have been between 39 and 45. Greater than 39, less than 45. And in fact, if we take a look at the temperature of that sample 1442, you can see the temperature was 43, so when it called the DLL, it returned back a value of just right. By side, you can see we created the object here in this statement. Then we set the property of the temperature. So here we have the set, so public property temperature. We passed it a value of the current analysis for temperature for that analysis here for that sample, and that value came in here and it ran through this logic setting the temperature label property. Then in this last statement, all we do is go and retrieve the value of the temperature label property of that object that we instantiated, and then we just return it back to the sample analysis as a calculated result. Analysis that we're using for the sample, so here's under analysis, and I created one called, notice it was Booz QA. If you double click on that, you can see there's only two components. One is called temperature, which is a numeric field, which I mentioned. The other one is a calculated value. The calculated value, if you see down here in the calculation, it's calling ComSpec. This is my calculation, okay? And that calculation has the code that calls the DLL, instantiates an object of the DLL, and then runs it. What you do is pick a limbs ML file that will pass in and automatically create a sample and process the calculations, and we'll see that in the next video.